Okay, so we're over at the lathe. This is my little plea for help. I'm sort of at a bit of a loss. I've got a little bit of a problem. I machine a lot of these. Yeah, basically it's just a little brass handle with a thread on the end of it. You know, the thread is just stainless steel, and then we machine a brass handle to go with it. Now, as it is, we machine these in two parts. So we machine this bit, and then we machine that, and then that's press fitted. Then there's a dowel put in the end to stop it spinning, because we did try threading them, but these get turned a lot daily, you know, back and forth, and even with Loctite they started coming undone. So here's my little problem, right? I can't get the brass to chip properly. Now I haven't got a problem with surface finish, but when I'm turning it, it's making such a mess that it's you know, I've virtually got to strip the machine down every time I do a set, and I do probably I don't know, perhaps 20 of these a month, you know, sort of regularly. So, and I think in total I got a few sort of 100 to do. So I want to sort of get it at least a little bit, yeah, that's plenty, a little bit better than what it is at the moment. You're probably wondering why it is that I'm using Forjo, and basically it's because I'm not that good at indicating. So I'm trying to use it more and more often, just to sort of practice. Doing it. So I've tried a few different tools. I've tried negative geometry tools, inserts, positive geometry inserts. I've tried positive geometry, high-speed steel. I've tried pretty much everything, and at the moment there's absolutely nothing that seems to be working. So hopefully there's somebody out there that that's machining brass. I might be able to shed a little bit of light onto the subject for me, because like I said, it's getting to the point where I don't want to do the job because it's making such a mess everywhere. So hopefully, like I said, somebody out there has had this problem, or is having this problem and has managed to solve it, and can perhaps point me in the direction that I need to be going in. Now, it's all it is. I mean, there's nothing special about it. It's just I put the grade up on the screen now. It's just free machining brass. You know, there's nothing special about it. You know, there's no reason why it should do what it's doing, as far as I know, anyway. hopefully, with the combined knowledge and wonders of the internet, we might be able to get somewhere. Because it gets in, you know, I'm having to strip the compound down, I'm having to, you know, clean all the tool holder out. It's everywhere, you know, and it's like a very fine splinters. My hands are full of brass, you know. I've tried coolant, I've tried no coolant, I've tried flood coolant, pastes, and just nothing that I seem to do seems to help. So I'm open to suggestion at the moment. I'm not sure exactly how round this brass is. There's this bar stop. Let's see if I can get on just on the end there. See if that's any closer. This is what I was saying about you know, needing to practice indicating. I think we get a little bit lazy with 3-jaw chucks, and when you get something that you've got to stick in a 4-jaw, you tend to have a little bit of trouble. Okay, that looks alright. Okay. Right, so like I said, I've tried different speeds, different feed rates, different tooling. You know, I'm at the loss. So I'll show you what the issue is. We'll run a few tools up there, and hopefully someone can help. Okay, what are we on? Let's try it. Well, we'll go for 400. Okay. We'll try. 4,500 per rev feet. Yeah, so okay, our first tool, what should we do first? Right. Okay. So first one is positive geometry insert. Yeah. You might have noticed that, hang on, I got my hoodie on. Yeah, I shouldn't really be doing this. Okay. I don't think you can see that, you know. I mean, no, that's no good, you can't see. Right, okay, let me just move the camera, and and we'll take a cut. I don't want to put the camera anywhere where it's going to get covered. Right. Okay, right. Let's try it there. Okay, so that's 400 RPM, 4 type of revolution feed rate, and let me just okay, okay, so we'll take okay, so that's 0.2 off the diameter, so it's the 0.1 depth of cut, yeah? Okay, here we go. Without the fair, so I was cutting threads earlier, so okay. Right, 400 RPM, 4-5 depth of cut. We'll take a bit more. Like I said, I'm not having an issue with surface finish. Okay, so I was let's take there we are. So that's half a mil depth of cut, mil off diameter, 400 RPM. Okay. Okay, let's take a mil depth of cut. I don't even know if you can see this. Tell you what, let's take so that's 1.5 mil depth of cut. Yeah? Okay, right, let's take 2.5 mil. Yeah, okay, so you can sort of see my issue, yeah, right? I don't know if you can bring that out a minute. See? I don't know if you can see that. Yeah? So that's my problem. Right, okay, so that's a positive geometry insert. Okay, I don't know if this one's going to fit in there now. Okay, next up we got, I don't know if you can see that, yeah, so this is just high speed, you know, quite a sort of severe rake on it, right? Okay. So we got same RPMs. I've got to be a little bit careful here because I haven't got a lot of tools stick out here. Okay. Right then, so hold on a minute. Let me just take a cut. Yeah. Okay, so this is high-speed steel, 400 RPM. Let's have a look. Got quite a big nose radius on this floor. So it'll take 2 mil depth to cut. Ready, here we go. Okay, so as you can see, same issue. Right, let's change the feedback. Let's take 7. Yeah. Right, okay. Same again. Down to catch up on that. 2 more depth cut, 7th out, the revolution. Still same issue. Okay, right. Tell you what, why don't we try, I'll tell you what, we'll do the negative jump first. Okay, so this is my sort of go-to tool. CNMG insert. Just touch off on that. Okay, so this is negative geometry. Depth cut, 400 RPM. And 7th out per rep. Okay, here we go. See, that's hand feeding. That's what I want, yeah, that's what I want. That, yeah, but that's like, I don't know, that's like hardly any feed rate whatsoever, that's on the hand wheel. Right, let's take that off there. Now, the lowest speed rate this machine has is 4.5 per rev. So is that my issue? I don't know. Maybe it is. Right. Why don't I try it? Let's try it at 800. Try 800 RPM. You know what? I think, to be honest, by doing that little experiment there to show you, I think I might have answered my own question, and that this machine hasn't got a feed rate short enough to do it. Even so, I mean, I don't know if you can see that. I won't bring the light over. I don't know if you can see that there, but even that's not great, So I'm gonna leave it there. I'm not gonna make any more mess because I've got to clear all this up now. So if anybody's got any ideas, just drop a comment or drop me an email or anything, please, anything. All right, let's carry on. Okay, so we're over at the mill. As you can see, we've got the old Bridgeport head mounted. Now, although it's mounted, I've still got a fair bit of work that I need to do to it. It's missing the flying feet handle and shaft and whatnot. The 12 feet I don't think is the original one, or it's been modified slightly, so we need to do another one of them. Now on the assembly drawing for these, there's a quill return spring shown in there. For some reason, now I don't know if this end plate, this end flanger has been remade, but there is no area there to fit a quill return. So we're going to do a little bit of machining on this and put the recess in there to hold the quill return. Right, I'm going to bring them a bit closer and I'm going to show you the adapter plate that I machined the other day. You're probably thinking that the vise is a little bit big for this mill. Well, it is, to be honest. I saw the vise on eBay, and it wasn't getting any attention. So I managed. I saw it, an 8-inch vise, and there was a picture of it. I've cleaned it up a bit. The jaws aren't great in it. I mean, I've cleaned them up, but they're not great. We need to make a new set of jaws for it. But I looked at the pictures and I thought, that'd be great, because almost everything that I do on here goes in the vise. Now I got a smaller 3-inch one, and I got a very, very long one. So I thought, right, that'll be tidy. So I managed to pick it up. It cost me 50 quid, right? So I mean, it's worth that scrap value. But what I didn't really put two and two together when I looked at the picture, and I'd looked at the picture and thought about it. It's past 8 inches, perspective wise, it's going to be, so obviously when I went to pick it up, it was a little bit of a surprise, and because it was on a swivel base as well. I mean, the swivel base is down by there. With the swivel base on it, I think it's probably bigger than the table, to be honest. But I mean, it's alright, it's great, and it probably adds another, I don't know, 50 kilos to the weight of the mill. So I'll bring you in a bit closer now. We'll have a look at the adapter plate, and I think we'll discuss the importance of doing sketches before you start on these little projects, because I dropped a bit of a bollock on this adapter plate, and it was stupid and a stupid thing to do, and it could have been avoided. So I'll bring you in a little bit closer now, and I'll explain what happened. Okay, so here's the adapter plate. This is the original mounting for the original vertical head. It wasn't actually. It was marketed as a vertical head, but it wasn't really. It was just a right angled head. There was no quill feed, and there was it could be used. It had 2 points of rotation, so you can drop it down in line with the bed. So I decided this came up cheap. It had a few issues with it. The feed was jamming, so the feed wouldn't work on it. And when I stripped it down, what had happened is it looked like somebody had tried to remove the the feed shaft to perhaps repair the fine feed. I don't know, but I think what they tried to do is they tried to drive it out with the quill still in there, and they just sort of chewed up some of the rack in there. Luckily, they stopped, but obviously not before damaging probably like a quarter of two of the teeth in there. But I managed to file them back down, and now it works fine. So that one a bad little steal there. Now when I made the adapter plate, I don't know if you can see. Yeah, you can. Right, if you look by here, right, there's a little register. Right. Now what happened was I cut this out of a bit of 15mm plate I had, yeah. And turned it down, and then my wife came out and told me off basically for working on my own little projects when I should be doing customers' work. So I left it. I left it up in the lathe. When I did the paying work as such, and then come back to it. And I wanted to put this register in there so that when the Bridgeport plate sat on there, it was always going to sort of sit, in the right place. Without thinking, I just went ahead and machined the register in the centre. Of course, this head doesn't sit in the centre of that plate. Now, of course, when I tried to fit it all up, the actual pulley housing was it in the back of this, and I mean that could have been avoided just by doing a simple little drawing, even for something as simple as this. Because I mean, all this is a disc with a sort of with a few holes in, and a little register, and I could have avoided that by just doing a little sketch. But I didn't, and it happened. So now I got two registers on it. Look, I even went as far as I doweled it and marked the top position, because there's a little recess machined at the back of it to clear some gubbins that are actually inside there. So of course, once I machined that out, I didn't have enough room then to machine the register again, and it caused a lot of problems. And like I said, they could have been avoided by just doing a little sketch. So I just thought I'd show you that, because we're all human and we all make these mistakes, and hopefully we don't make them too often. Now I don't know if there are any Bridgeport fanatics out there. I'm sure there are, but if anybody's got a quill drawing, quill dimension drawing, I wouldn't mind having it, because at the moment there's let me just move the camera a minute so you can see this properly. Yeah, so I don't know if anybody's got the dimension quill drawing, but at the moment this is an M head, so it's got a 2 empty taper in there. But if you look at the bottom of the quill, right, previous owner, or the previous owner, has decided that it might have been a good idea to drill and tap the quill, the quill. So I mean, it's not causing an issue. I mean, there's nothing on the inside sort of in the way or causing an issue, but it just looks ugly, basically. Not only that, that was his second attempt, because the first attempt went terribly wrong and he snapped the tap in there, and that's still in there. Yeah, so and I was wondering, I don't know how much meat I got there, but I wouldn't mind opening this up to a number 3 Morse taper. So I mean, if anyone got one, I can't find one on the internet. Anyway, I can find loads of quill drawings, but none sort of dimensioned, so I can see. I don't really want to strip it all out unless I know I can do it, but obviously if I can do it, then I'll repair these ugly holes at the same time. So there we go. Also, if anybody's got a drawing of the micrometer assembly, yeah, with thread sizes and whatnot, that'd be great as well, because I need to make something to go on there. I know the bottom one. Yeah, I got a tap for that. That's like a 5/8 worth, I think, or something. You know, I got an old tap that. Yeah, so that's that thread, but I don't know the size of the thread for the micrometer, or you know what parts go on here. I'm also not so sure about this bit. I'm not sure if this has been, maybe they had a DRO on there or something, but looking at the drawings, the assembly drawings I got, that bit isn't, you know, isn't present. There's something slightly different, but there. So if anybody's got them, let me know or drop me an email. It would be very much appreciated. Okay, right. Oh, while we're here, I'll tell you what. We'll have a look at some of the other stuff we got here. Okay, so not particularly interesting, but obviously, like I was saying, this is a 2 empty spindle in there, so I didn't actually have any sort of tooling, because most of it is three empty tooling. So I decided, I had one of these. Well, I had a few of these soft stub arbors about here in 3MT, so I decided that I was going to have a little blast that I'd turn in a Morse taper. So thanks to Tom Lipman's short series on turning tapers, it came out all right, to be honest. Like I said, this was a trial one, so this one had a little bit of a batter in. I can't remember what I used that for, but yeah, I can't remember what I did with that. But anyway, this end of it, the blue is still on there. Yeah, so I think you can see it. I believe that the top is relieved there, but that's come out of the quill, out of the spindle. You know, there's a few patches, you know, on there. I probably should have polished it a little bit, perhaps. But you know, I think for all intents and purposes, for the first time, I mean, that's the first taper that I've ever turned. I think it came out all right. So I was quite happy with that. Yeah. So there we go. I'm now in two minds whether to turn the rest of my tooling down now to that size, or whether to just to go and just to sell it and buy new. But the problem is that the lathe, the tailstock and the lathe, that takes 3 empty, so I don't really want to, this it's a bit of an awkward one. But anyway, so yeah, that was my first Morse taper. I'm quite happy with that. Oh, by the way, I clocked it up in the spindle. And I had about two hundredths of a mil run out on it. And when I clocked the spindle when I first started, there's 200ths of a mil run out on that. So I think that was pretty good.